as Dave Bidwell said. I am Kim Hall from the Nature Conservancy, and my co-author on this talk is Patrick Doran up in the stands up there. So what I'm going to talk to you today about is a project that we had funded last year that focuses on trying to understand the sensitivity of the practices that we use in trying to protect freshwater ecosystems from the impacts of neighboring agricultural practices, and also looks at the models that we use to evaluate those practices and scale them up to larger areas. And as Tom was saying earlier, this is one of those cases where you have, first of all, a very complicated system. So you have lots of different choices going on in the landscape, you have lots of variation in the landscape, and you have lots of uncertainty in the climate impacts and the timing of those impacts. So already there is a lot of kind of uncertainty and hand-waving that goes on when you try to describe how these impacts may affect how we at the Nature Conservancy and other agencies look at how to better protect those systems in the future as climate change continues. The other piece here that's really important to understand is that, as Tom also said, this is a case where there's a lot of very pressing issues to deal with right now, and climate change is often in the background, and often those unstated assumptions about climate persist in the models and tools that we use. And it's important to kind of bring those assumptions to light and say, okay, when you have a model that looks at rainfall or looks at temperature or looks at how evaporation works, is that underlying assumption still likely to be credible as the climate changes? So that was really the focus of our work, and that's what I'm going to try to describe here. So the problem, how do we update our strategies to protect our freshwater systems in these agriculturally dominated landscapes? And one of the things that Dave asked us to talk about today was, who are we engaging in this? Who are our stakeholders? How are we acting as a boundary organization? In this way, the Nature Conservancy is definitely a group I would consider to be a boundary organization, in that we are really focused on getting good science integrated into conservation decisions. In the case of this one, we were also a stakeholder, though, because a lot of the information that we're trying to pull together here and understanding how our toolbox works in agricultural strategies is sensitive. That's stuff we want to use ourselves. So we're kind of on the boundary, and we're also one of the stakeholders. So what are we talking about in terms of impact? Specifically, we are focused on trying to understand how erosion and the resultant movement of sediments into freshwater systems will change as a result of climate change, and how all of the associated nutrients that are used in agricultural systems and contaminants, fertilizers, pesticides, how are those likely to move, and how are those going to change as a result of climate change. And the goal here is to basically take some first steps forward towards identifying some big problems with the current tools, if there are big problems, what are the highest priority things to address, and help direct a research and management response to improving the toolbox that we have. So both improving the on-the-ground practices, which are illustrated in that top picture, all the different things that you can do in the agricultural landscape to reduce the impacts, and also to improve our tools, such as our modeling tools illustrated in the second picture. Our approach was basically to review a lot of literature and also do some kind of carefully targeted expert opinion and review, and that's still going on right now. But just to give you a sense of the kinds of things that we're looking at, in the table here I've shown some of the ecological benefit ratings for a subset of conservation practices that might be applied in agricultural landscape. And going down the list there's conservation cover, pasture and hay planting. These are things that you would do to try to reduce the impacts. Going across the different numbers and columns there are basically giving you a rough indication of to what extent do those practices provide some kind of ecological service. So the first column there, sediment, if it gets a higher number, the 3 was the maximum here, that's saying it does a good job of keeping sediment out of the water. And goes across to looking at some other services like keeping phosphorus out, maintaining natural flows, those sorts of things. So these are data that we had pulled together in the context of developing our strategies in the agricultural setting. We want to know what happens to those numbers as climate changes. So if peak storm intensities increase, do those services basically keep performing the same way? Do those numbers go higher or low? And you're seeing we're not looking at something really precise. We're just looking at relative rankings of performance. So some of the questions we were looking at, how do peak storm intensity increases, which are one of the more higher confidence impacts for our region, affect the performance of those practices? what happens when growing season length increases or summer drought stress increases. And in the back of our minds all the time, the question that we're asking is, how many more acres of a practice do we need to get on the ground to have the same benefit or to have improved benefits? So that's the context. So what I'm going to do is just walk you through one example, and this focuses on the service of keeping sediments out of our freshwater systems under the prediction of increases in peak storm intensities. So this is a model that is very complicated that I won't go through right now, but this is a tool that we've been using that's been developed from the Water Resources Institute at Michigan State, and it's called the High Impact Targeting Model. And what I'm going to do is just kind of give you a sense of what this kind of investigation and poking at tools looks like. So it's got a lot of different pieces in there. From my perspective, the most important thing on climate change sensitivity is the assumption that it makes about rainfall, and particularly rainfall intensity, which is represented in this model in the R factor, which is part of the Russell equation for estimating erosion that's related to rainfall. So just to highlight that piece, again, I'm just going to focus on that little piece of a complicated model. There are probably other pieces that are climate sensitive. And so this is me brainstorming on, okay, how would I try to think about this when there are no projections that are specifically tied to rainfall erosivity as it's put into that model, at least that I have found so far. And the things that I started putting together in my mind were, okay, everyone is probably familiar with the Moving Michigan map from the last National Climate Assessment, I think 2009. Okay, so if we know that the temperature and precipitation are likely to change, and the projection here is just as an illustration suggesting that under the higher emission scenario, which are the red, we'll be getting climates more like northern Texas, for example, in the later time periods, more up near, what is that, like Arkansas or something, in the medium time scenario. What does that mean in terms of trying to understand what could happen to rainfall erosivity? And this on the right is a map of the current map that describes how that variable, which is a key component of many models that look at soil erosion, varies across the geography. The light yellows where we are up in Michigan are vary between like 60s, 80s. Getting towards those parts of the country that our climate is suggested to shift toward, the values get much higher. And if you happen to be able to read those little numbers on the right, you'll see that the first sets of isoclines go down by tens. But as you get down to the southern part of the country, those are going up by 100 per change in color. So it's not a linear change with a linear pattern. So I basically took that information, plugged it into this tool that we've been working with the Michigan State folks on, that we've also worked with them to develop a web interface so that people can look at the impacts of changing their conservation practices at the field scale level or also at the watershed level. And I'd be happy to talk more about this, and Patrick would as well. We don't have much time here. But this is a tool where you can basically digitize a field and then calculate what happens as you change practices. So if you just look at the current R value, the current rainfall erosivity value, these are the different values of erosion that this model predicts that you would get, with forests being no change in land cover, and then far over there on the left side would be just conventional tillage. Looking at that over a range of rainfall erosivity values, these axes are lined up. So you'll see that the projection for changes in erosion as you change that erosivity value become quite high, especially as you compare the conventional tillage, for example, to the forest, which stays pretty flat. So this is just one example of the types of information where we're trying to translate the climate impacts to metrics that we can then have this conversation about how do we update our tools and models.